Let's see how we can use a truth table to assess the validity of this argument. Our argument has two premises and a conclusion. The two premises are, first, if A, then B and not C, and secondly, if not A, then C and not B, and the conclusion is B or C and not B and C. Now just add a little exclamation mark to remind myself that this is in fact our conclusion. I've here already constructed the reference column. We have 3 atomic sentences and therefore a reference column with 8 rows. Let's start by filling in our first column in the assessment column for our first premise. So the main connective here is a conditional, and the consequent of the conditional is the conjunction B and not C. Now I'll start with the innermost connective, which is the negation sign. So the conjunction sign has the negation in its scope, and so that means that the negation sign is the innermost connective. And the negation sign simply flips the truth value of C. So I'm just going to look at the column under C and reverse all truth values. Okay, and now to assess our conjunction, I need to look at 2 columns. I need to look at the column under B, and I need to look at the column under not C, since the conjunction is true just in case both B and not C are true. So that means in the first row the conjunction is false, true, false, 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 true, and false. So that's the assessment of our conjunction. Next, let's look at the conditional. Now the antecedent of the conditional is the sentence A, and the consequent of the conditional is the conjunction B and not C. So that means that in order to assess the truth value of the conditional, I need to look at the column under A, and I need to look at the column under the conjunction sign. And the conditional is false in just one case, namely when the antecedent is true and the consequent is false. So let's see what truth value it has on the different valuations. In the first row, the conditional is false, since A is true, but the conjunction is false. In the second row, it's true, false, true, false. No, that was actually true. Both antecedent and consequent are false, so that means the conditional is true. False, true, and true. So that's our assessment of the first premise. Okay, next let's look at the second premise. I'm again going to start with the innermost connective. Now in this case we actually have 2 innermost connectives. This negation sign and this negation sign. In a case like that where you have 2 innermost connectives, you can start with either one. They are both negation signs, so the first negation sign flips the truth value of A. I'm going to start here. So this is F, 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 T, T, F, T, and T. And then the second negation sign flips the truth value of B. So that's going to be F, F, T, F, T, T, F, and T. All right. negation is done. Next we need to look at this conjunction sign here. Now the conjunction C and not B is true just in case both C and not B are true. So we need to look at this column here and at this column here in order to assess the truth value of the conjunction. So the conjunction is false, false, true, false, true, false, false, and false. To complete our assessment of the second premise, we just need to fill in the column under the main connective, which is the conditional here. So the conditional, the truth value of the conditional depends on the truth value of the antecedent, which is not A, and the consequent, which is this conjunction here. So let's see how that works. The conditional is true in the first case, given that the antecedent is false. True in the second row, true. Now in the fourth row, the conditional is false, given that the antecedent is true and the consequent is false. And then in the fifth row, it's true, true, false, and false. Okay, that was the assessment of our second premise. Let's finally look at the conclusion. So we again have two innermost connectives, the conjunction and the disjunction. Let's just start with the disjunction. The disjunction is true if either B is true or C is true. So it's true, 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 false, true, and false. Then the conjunction B and C is true if and only if both B and C are true. So that's true, false, false, true, and then false all the way down. Now let's look at the negation before the conjunction. This negation sign here simply flips the truth value of the conjunction. So I will write this out. False, true, true, false, true, 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 and true. And the last thing left to do is we still need to fill in the column under our main connective, which is the conjunction sign. And to do that, we need to look at the truth value of the disjunction and the truth value of this negated sentence. And the conjunction is true if and only if both the disjunction and the negated sentence are true. So that means it is false, true, true, false, true, false, true, and false. Okay, so that is our complete truth table for both premises and the conclusion. Let's finally try to use this truth table to figure out whether this argument is valid. Now the argument is valid if and only if every valuation that makes both premises true is also a valuation that makes the conclusion true. So let's see where both premises are true. We need to look at the column under the main connective of the first premise. And we also need to look at the column under the main connective of the second premise. Now, where are both of these true? Well, that's the case in the second row. And then again in the fifth row here. So we have T, 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 T. And that's it. So there are only two valuations that make both premises true. Now the question is, do these valuations also make the conclusion true? So we need to look at the column under the main connective of the conclusion, which is this column here. And we see the conclusion is true in the second row and in the fifth row. So yes, the answer to our question is, this argument is valid, given that every valuation that makes both premises true also makes the conclusion true.